Okay, basically what we've got here is a program written by a guy at processing.org whose name is Daniel Shiftman. He's one of the tutors and founders of the processing program, which is a Java-based programming. I'm using his program, but I did make a few adjustments. For one thing, I increased the size of the screen. I increased the number of original birds in the original flock. I changed the color of the background. I slowed the birds down so you can see better what they're doing. And I added a cute little routine that I'll show you in a minute. But basically, this is an algorithm called a flocking algorithm, and it involves complex behavior, and it involves emergence, which is the reason I'm making this video, to be a demonstration of the principle of emergence, which is typical of all complex systems, as I understand it. And the little routine that I added is one that will increase the number of birds in the field by 50 each time I click the mouse. So I've just added 200 birds to the system. Now, every time I add birds, it'll slow the process down a little bit. That's not a function of the algorithm. The algorithm simply says this: fly at a constant speed and maintain your same direction unless the birds nearest to you get closer than 20 pixels. Your job is to keep flying at the same speed and keep the birds nearest you at a distance of 20 pixels. And of course, at some points they're going to get scrunched closer, and some points, but they should never get more than about 20 pixels away from each other. No individual bird knows anything about the flock. All it knows about are the birds immediately adjacent to itself. Okay? And the emergent behavior here is that the flocks form, reform, separate, sometimes move in one direction, sometimes move in another. So I'm going to add just a few more 100 birds, and of course this will slow down the computational speed because the computer can only make so many decisions at once. And then I'm going to just be quiet and let the program run, and you can watch the emergent behavior. Again, the only rule is that each bird try to maintain a distance of 20 pixels from any other birds. The flock itself is formed out of that individual agent's behavior. Sometimes a few individuals like these up here will seem to be flying independently of the flock. That's simply a result of their following the rule. Now they've merged with the flock. It's also written so that when the birds fly off the right side of the field, they'll appear again on the left side, is something you can see right now, flying off the right and emerging again on the left. The same thing with the top and the bottom. If they fly off the bottom, they'll emerge on the top. If they fly off the top, they'll emerge on the bottom. So this pretty well maintains a constant number of birds in the field at all times. I'm only going to allow this to run for 5 minutes, and we're already at almost 4.5. So I'm going to throw in a few more birds, see if we can. That incidentally creates turbulence when I do that, and the turbulence involves a period of chaos until the emergent properties take over or reformulate themselves. So we are at now 5 minutes, and I thank you for watching.